the third of those 3 miniature lectures that I wanted to share with you about some specifics regarding hypothesis testing that are going to be important to know as we move forward learning in the field of statistics. Now, I said last time that statistical significance may not mean what we think it means. It simply means that it is unlikely that we would have found the results that we did if the null hypothesis was true. It's unlikely this result would have occurred by chance. But when we set our p-value at 0.05, we are saying that we are willing to accept a 5% chance that we're going to be wrong. If we do enough tests, it's likely that we will be wrong eventually. We'll make a type 1 error. I said that the solution for that problem was to also report an effect size whenever we report statistical significance. So let's dive in. What is an effect size? An effect size is a standardized measure of the size of the effect, and this allows us an objective evaluation of the size of the effect. Statistical significance is the probability that we would find these results if the null hypothesis was true. But the effect size answers the more important question, or at least the equally important question, of how big was the effect? The effect being the difference between the sample mean and population mean, or between the 2 samples that we're comparing. Any of the comparisons that we're making, how big was the difference? I want to illustrate this using a tale of 2 studies on effects of leadership style on productivity. There are 2 programs that we want to examine, A and B. And what's important to know at this point is that the researcher we will call Jones created program B. Smith created program A. So we'll just use those 2 as a convenient shorthand for the creators of the programs because they each did an evaluation. Now Smith created a program, he wrote up the results of his program, and here's what he found. That T with 78 degrees of freedom, 2.21, P less than 0.05, his program made a statistically significant difference in leadership. Well, Jones, who you remember created program B, replicated this study, and here's what he found. T with 18 degrees of freedom, 1.06, P greater than 0.30. In other words, not statistically significant. Non-significant. So one researcher studies a program and finds there's a statistically significant difference. The other one studies the same program and finds out there's no difference. And this leads to confusion and skepticism, because people who don't really know statistics very well would say you can't trust science because they don't agree with each other. One finds one thing, one finds something else. But the truth is, no. If you understand the statistics or have someone who can explain it to you, you'll find out that there is no disagreement with these findings. What we're going to do is use these findings to report an effect size. And we do that using a formula. It's simply 2t over the square root of n. We multiply 2 times the t value divided by the square root of the effect size. And for Smith, we get a value of 0.494. When we do that same formula with Jones's research, we get an effect size of 0.474. 0.49, 0.47. Those are essentially the same effect size. Both of these researchers found exactly the same thing, that program A leads to a difference of approximately 1/2 of a standard deviation. And that's really good. The difference between significant and non-significant in this case was due simply to the sample size. Smith's study had more power to find differences. More power, greater sample size. And be sure that you're not led astray by the idea that if one study is significant and the other study is non-significant, well then the significant study is better than the non-significant study, or the program studied in the significant example is better than the non-significant example. The difference between significant and non-significant is not itself statistically significant. One program, statistically significant, the other research program, non-significant, but they actually both had the same finding when we examined it in terms of effect size. The person that we have to thank for the popularization of effect size in statistics is Jacob Cohen, the inventor of something we call Cohen's d, very widely used with t-tests. Anytime we're comparing two groups, Cohen's d will give us a clarification of how large the effect size was. Here are the conventions that Cohen recommended for us. You see them in bold. Effect sizes of 0.20 are small, 0.5 are medium, and 0.8 are large. Another researcher added some other conventions that we could apply. For instance, 0.10 is very small, a 1.2 is very large, and a 2.0 is huge. Now you might ask yourself, where do these conventions come from? What do they relate to? Well, technically what they are is measures of standard deviation. If you have an effect size of 0.5, that means the difference between the means was half of a standard deviation. However, these conventions are arbitrary. But Jacob Cohen answers this by telling us that all conventions are arbitrary. One can only demand of them that they not be unreasonable. And that is the case with Cohen's d. It gives us a good way of measuring effect sizes in different studies so that we can compare them. Why should you report effect size? Well, the first reason might be as simple as this. APA style recommends it. The APA says, mention all relevant results. Be sure to include small effect sizes or statistically non-significant findings. So having that recommended to us by the APA is important, but maybe you're someone who says, I don't want to be told what to do. Why should I do that just because the APA recommends it? Well, I have other reasons why you should report effect sizes. The first is this. If you are doing a study in which you're not trying to generalize, you're just trying to see whether this particular drug works or this particular study is worth pursuing, if you're not trying to generalize, you're just testing, well then it's important that we know how big of an effect this drug or this program is having. So if you're not trying to generalize, it's very important that you report the effect size so that other researchers can use that for doing statistical hypothesis testing. They'll use the effect size to create a power analysis, and they'll know how many people they're going to need in their sample to find statistically significant differences. Now, on the other hand, if you're doing hypothesis testing, but you have very small sample sizes, it's likely that you will find non-significant results, but that's really a type 2 error. It may be that you would find a statistically significant difference if you had a larger sample size. Therefore, if you are using small sample sizes, it's important that you report the effect size as well. That will allow us to determine what sample size would be needed to find statistical significance. Now, on the other hand, if you're using huge sample sizes, I remember doing a project in which we had 2,000 or more high school students who were participating in a program in their high school. And where we're doing tests, every test that we ran was statistically significant because that sample size was huge. Well, if every test is statistically significant, we're not really learning too much, are we? So it was important that we reported the effect size so I could show you, yes, this result was likely not due to chance, but here's the actual effect that the program was having. Therefore, the conclusion is there really is no good reason why you should fail to report an effect size anytime you do hypothesis testing. Well, that brings us to the end of the session and the end of the class. So I want to thank all of you for being here, for being part of this class, for being part of the learning experience. I teach basic business statistics and applied business statistics, so you're welcome to join me in the future if you're looking for an applied business statistics class. We'll pick up where we left off and continue to learn. So regardless of where the future takes you, I wish you the very best. Thank you for being part of the class, and I'll see you down the road. All right.